In language learning, everybody talks about strategies for learning a language, but nobody really talks about how language works, how our brains process language. What if the way that we think about language is wrong? That's a question I asked myself a couple of years ago, and it sent me down a rabbit hole of research trying to get an idea of what the consensus is amongst linguists about how our brains process language. In this video, I'm going to talk about a new perspective on language that a growing number of linguists are very excited about. When I learned about this, it completely changed the way that I think about learning languages. Let's start by defining the basic mental model of language that we all seem to have, which I'm going to call the Lego block mental model of language, that says that language is made up of building blocks that we call words. We assemble these building blocks into sentences using mysterious rules that we call grammar rules. And somehow our brains just know how to do this. This way of thinking about language can actually be traced all the way back to Benedictine monks who were trying to make sense of Latin manuscripts. By then, Latin was a dead language because the Roman Empire had fallen. Many of the Catholic Church's most important manuscripts were in Latin, and they wanted to preserve those. So scholarly monks spent thousands of hours reverse engineering the language, trying to find patterns that they could extract into rules, and then they could use those to translate these manuscripts into Greek. In the 14th century, that was the rise of universities, and by then, grammar had become more of a formal system that was taught to students as a way to analyze and learn languages. So what happened was that this system for decoding languages over hundreds of years just became the way that we thought about languages. Fast forward to the 1950s, a very famous linguist, Noam Chomsky, formalized this way of thinking about language into a theory called generative grammar. The core idea of generative grammar was that our brains are computing all of these grammar rules. Chomsky's big idea was that humans, all of us, are born with a module in our brains that is able to encode all these syntactical grammar patterns and decode them on the fly as we're listening and speaking. So at this point, I should probably talk about the word grammar, what that means to a linguist and what it probably means to you. So for you and I, when we hear the word grammar, we probably think of a rule in a textbook like adjectives that modify a noun must come before the noun. So red must come before car. You can't say car red, you have to say red car. Whereas for a linguist, a grammar is a kind of schematic that describes all the underlying logical systems that exist within the language. So Chomsky's grammar was more like a mathematical notation. It was full of these formulas, and he was documenting these much deeper, subtle, somewhat mathematical patterns in language. This was really exciting at the time because it described language in this really beautiful, elegant, mathematical way. And Chomsky's theory further reinforced this notion that language is made up of words that are organized and coordinated using this vast system of complicated grammatical rules. Generative grammar as a theory dominated the field of linguistics from the 50s until around about the 80s. At some point, the theory started to run into problems. Chomsky arrived at his conclusions about language by analyzing hypothetical sentences on paper. But when linguists analyze the way that people actually speak in real life, they found that we tend to speak in fragments, utterances, and we rely on people around us to infer what we mean. And it's generally only in written language that you see these perfect, fully formed sentences. This created a problem for generative grammar because the theory was predicated on the idea that our brains are calculating the syntax using these rules that determine how a complete sentence should work. While Chomsky's theory was elegant, real language is messy. Around the 1980s, when the computer revolution came about, linguists started doing data analysis on huge data sets containing millions of sentences. These were collections of books and documents and things like this. The Lego block model of language says that with grammar rules, we can arrange these building blocks called words into infinite possible sentences. But an important discovery was made from analyzing these data sets that real language was actually made up of these repeating sequences of words. Just to give you some examples, I'm going to head out. Can you give me a hand? Can you keep an eye on this? Just a second. Language is full of these phrases that come up over and over again. Or you wouldn't call these phrases idioms. They are actually idiomatic. For example, keep an eye on. It's not literal. For somebody learning English with traditional grammar rules, it's difficult to make sense of that. You have to know the idiomatic meaning of how I is being used in that context and what this sort of idiomatic nature of that phrase. And that raises the question, well, what if all these fragments of language are actually idiomatic? So that the meaning is not in the grammar rules and in the individual words, it's actually these sequences of words that have an idiomatic meaning that's associated with it based on our ability to recognize a specific sequence. So, for example, you could say to somebody, put your eye on that, but that doesn't have the same meaning as keep an eye on that. It's the specific sequence of keep an eye on that conveys that specific meaning. In the late 80s, early 90s, a new theory began to emerge called construction grammar. Two researchers, Fillmore and Kay, had this big discovery that while there were all these repeating fixed phrases like keep an eye on that, that we discussed earlier, there were also partially fixed phrases that were schematic. And by schematic, what I mean is that they had fixed words that were always in the phrase, but there were slots where you could add different words to make different meanings. And they called these constructions. This was exciting because it meant there was now a possible explanation for why communication of complex ideas was possible without needing to have all these complex grammar rules on our heads. We just need to remember sequences and know how to use them creatively, and we can communicate anything we want. So, for example, the what, X, doing, Y construction, where X and Y are placeholders where words and phrases can be slotted in to create a sentence. What's this coat doing on the floor? What's interesting there is that the meaning is coming from this specific pattern of words. Traditional grammar would try to explain or assume that the meaning comes from the syntactic rules that are supposedly being followed. If you were to interpret it through those rules, it would be literal, as if the code has some kind of agency and it's alive and it's moving around or something. But you and I both know when somebody uses that pattern of words that they're communicating frustration, that they're actually implying that the coat should not be on the floor. Later on, Adele Goldberg started documenting more complex examples of constructions. Let's talk about the caused motion construction. She sneezed the napkin off the table. Makes perfect sense, but not according to traditional grammar rules. It turns out the reason we know that in this phrase the word sneeze is causing something to move, not from the fact that the verb is transitive or whatever, it's because of the specific arrangement of words that surround it, the construction. The construction has a specific schema. There is a subject, as in she. There is the verb, sneezed, and there is the object, napkin, and then there is the directional phrase, off the table. To give you other examples of sentences or utterances that follow this pattern, she laughed him out of the room, where she is the subject, laugh is the verb, him is the object, and the directional phrase is out of the room. That's another example of a verb where it's obvious that we're inferring the meaning from the surrounding arrangement of words, because laugh is not a verb that causes things to move, except when you use it this way. Another example, he smiled his way past security. If we are not inferring the meaning of the phrase from some subconscious knowledge of specific types of verbs, we just know what the word means based on the construction, the surrounding arrangement of words. What are the implications of that? So the first one is that we don't need to understand complex grammar rules in order to communicate complex things. We just need to know the specific arrangements of words and what meanings they refer to. That's a lot simpler from the perspective of the brain. It just means that we're making simple associations in the brain between arrangements of words and meaning. We're not doing all this complex grammar rules. The other implication is that meaning is not localized to individual words. Words are malleable. This is why words can have seemingly infinite different nuanced meanings depending on the context that they're used in. And that's because language is full of these constructions that are shaping the meanings of words depending on what words we slot in to the constructions. Another really interesting implication of construction grammar is that we now know how and why comprehensible input works. When Stephen Krashen originally came up with his big idea about comprehensible inputs, he was working within the framework of Chomsky's generative grammar. His assumption was that we don't need to understand grammar. That's all explained by generative grammar. It's just this subconscious process. But construction grammar has a better explanation. For example, because constructions allow us to infer the meanings of words, then we're able to learn a lot of words very quickly once we know a single construction. But not only that, knowing a given construction actually makes it easier for you to learn other constructions. And research has shown that this is how children learn language. One of the first things a child or a learner of English will learn is the phrase, I don't. And once you learn I don't, then you start picking up I don't know or I don't like. And once you know I don't like noun, for example, I don't like cake, then it becomes easier to learn you don't like noun because all you're doing is swapping one word. This is what I+1 really is in the brain. In immersion learning, most people define I+1 as just a sentence where you don't know one word. What really goes on in our brains is that when we understand the construction in the absence of one piece, then that is what allows us to infer the meaning. If you know the construction I don't like, and you hear somebody say you don't like for the first time, that's a variation of the construction that's very easy to internalize. Through this, you get this bootstrapping effect where you are just building upon things that you already know. It's not a process of knowing a long list of words and then your brain just figuring out mysteriously how to put it together with some subconscious grammar. It's your brain is recognizing arrangements of words and the meanings that are associated with those arrangements. So what are the implications of this if you're a language learner? The obvious one is that our brains are not processing complex grammar rules. We are actually just creating mental associations between a sequence or pattern of words and what they mean, which means that it doesn't really make sense to study and memorize grammar rules. It makes more sense to study constructions and understand what they mean contextually. The other implication is that studying too much grammar with the wrong mental model of what is going on in language can actually be damaging to your ability to speak the language that you're learning. And we actually see this in a lot of language learners, that they overgeneralize these grammatical rules that they've learned. They've mastered the grammatical rule, but they make all kinds of grammatically correct sentences that just don't really make sense. What I talked about at the beginning of the video, how we think language works, is really important, because if we have an incorrect mental model of language, it leads to us making all kinds of incorrect mental associations between what things mean and what they look like. The most important implication is that, yes, you should be learning from inputs. However, I don't think it actually makes sense to focus on learning individual words in isolation. Given that language is actually made up of predictable sequences, you should focus on trying to find these repeating multi-word patterns in language. And one that we're all familiar with is collocations. For example, we always say Merry Christmas, not Merry Birthday. And it's because Merry has a certain connotation that's associated with Christmas. If you're interested in learning a language this way, or you have any questions for me about things I've talked about in this video, click the link in the description and you can join the Verbalized community. It's a place for people who are interested in learning a language in a way that's aligned with all the most recent research on linguistics. It's something I've been reading about for the last 3 years. I've got a lot to talk about. I've got lots more ideas for videos. So if you have any ideas, please comment them below. And if you've watched this far, I really appreciate it.